Okay, welcome back. In this unit, I wanted to go over some of the homework. Usually I don't go over every page, but these structure diagrams are a little bit more complicated, so I wanted to have a chance to go over this classwork. Now, this first example on this page says we're going to bond the carbon to the hydrogen. So we look on the periodic table and we see that carbon is in family 4. So that means we know it has 4 valence electrons, and its oxidation number is 4+, so it needs to make 4 bonds. Okay, and we look on the periodic table. Well, let's do the dot diagram for carbon. So it has 4 valence electrons. It should have 4 dots in its dot diagram. Okay, and we can put these others in the trash because we don't need it. Okay, now the hydrogen we look is in family 1, so it has 1 valence electron and its oxidation number is 1+. So let's do its dot, and so the number of bonds is 1 because of its oxidation. We do the dot diagram. Hydrogen has 1 dot for its 1 valence electron, and we can throw the rest of these unused electrons right here into the trash. Okay, now for the number of atoms needed, we can crisscross the oxidation numbers. We can take this 4 and put it down over here by the hydrogen. We can take this 1, the oxidation number of hydrogen, and put it down over here. So that tells us we need 1 carbon in this molecule, and we're going to need 4 hydrogens. And we see that they're going to be single bonding because I said in the instruction video to circle the smallest number of bonds, which would be 1. That's our choice. Okay, so when we look at the chart, we would pick carbon that looks like this, 4 single bonds. We said we need 4 hydrogens, and we need a hydrogen to hook onto every one of these 4 places. So we need 1 for there, we need 1 for here, we need 1 for here, and we need 1 for here. Now, each one of these lines represents a pair of electrons. It's a single bond. It's 1 pair of electrons being shared. So let's look at this first top single bond and put in this pair of electrons. And this single bond right here is this pair of electrons. And then this single bond down here is this pair of electrons. And then this single bond over here is this pair of electrons. Now we look up here at the dot diagrams we made, and we see the carbon should have 4 dots in its dot diagram. And it does. It has 1, 2, 3, 4. It's sharing 1 of its 4 electrons, with each of the 4 hydrogens. Each of the hydrogens has 1 dot in its dot diagram, and it's sharing it with the carbon. So the hydrogen has a full outer energy level of 2 with the electron that it owns and the one that it's sharing. And the carbon has a full outer energy level of 8. So everybody's nice and happy. Everybody has full energy levels. Okay, and this molecule is going to be stable. And our formula is CH, and there's 4 H's. When we go to name it, we don't do anything to the name of the first element or if it's the only element. So we're going to write carbon. And then we see this 4. Okay, so the 4 by the hydrogen tells us it's tetra. And we put IDE on the end of the second element, so it's hydride. Okay. Now, the second example here, it says we're going to bond nitrogen to a hydrogen. So we look on the periodic table and find out nitrogen is in family 5. It has 5 valence electrons, and it has an oxidation number of 3. So we're going to put 5 dots on the dot diagram for nitrogen to represent these 5 valence electrons. And we don't need these other 3 electrons, so we're going to dump them into the trash. And we look on a periodic table, and we should know by now hydrogen's in family 1. It has 1 valence electron and an oxidation number of 1. So we're going to put the 1 dot in hydrogen's dot diagram, and we're going to get rid of these extra electrons that we don't need. Okay. Now, again, to think about the number of atoms that we might need in the formula, okay, we're going to take the oxidation numbers and crisscross them. So we're going to take this 3 and put it down over here by the hydrogen. And we're going to take this 1 and put it down over here by the nitrogen. So this tells us that we expect to use 3 hydrogens. Hydrogen can only share 1 electron. So it can only single bond. That's all one little hydrogen can do. So we would circle the smallest number of bonds, and our picture should match single bonds like this first dash. So if we look at our chart, okay, nitrogen can make 3 single bonds, which makes sense because we said we need 3 hydrogens to hook to each one of these places. So we could hook a hydrogen here, we can hook one there, and we can hook one here. Okay, and with that, all the connections are used. We ended up with 1 nitrogen and 3 hydrogens. To make that diagram, you put down the same symbols. Okay, so you end with the 3 H's. Remember now that each line represents a pair of electrons. So we have a single bond here. We have a single bond here. We have a single bond here. Okay, and a single bond is a pair of electrons because they're being shared. So that's why I use these colors. You can see that one of them is from the hydrogen and one of them is from the nitrogen. In every case, okay, it's a pair of electrons and each one is sharing 1 electron. Now we look up here at the dot diagram for nitrogen. Nitrogen should have 7 dots in its dot diagram, but we've only got 3 here, 1, 2, 3. So we need to add the other 2. And when we do that, look what happens. There's 8 electrons around the nitrogen, so it has a full outer energy level. Each of the hydrogens has 2 electrons, including the ones that it's sharing. So that means it has that full outer energy level, and then we don't need these other pieces. So we'll stick them in the trash. And then our formula is 1N, 3 H's, so it's NH3. The name of the substance is going to be nitrogen. And then we see the 3, so we're going to say tricycle. And then if the second element is when we use IDE, so it would be nitrogen trihydride. Now this last one on this page says that we're going to bond carbon to chlorine. So we look on the periodic table, and we've done some carbons already, so we know it's in family 4. It has 4 valence electrons, and its oxidation number is 4. So because it has 4 valence electrons, we're going to put 4 dots on its dot diagram. We're going to throw the other ones into the trash because we don't need them. We're bonding to chlorine, and we find out if it ends in INE, it's in family 7, and it has 7 valence electrons. So we're going to put the 7 dots on its dot diagram. We're going to throw this extra one away. Chlorine has an oxidation number of 1, so it needs to be 1 bond. This is where we can crisscross our oxidation numbers. We can take the oxidation number of the carbon, which is 4, put it over here, because there's going to be 4 atoms in the formula. We can take this one here, put one here. Okay. Now, chlorine only has one place where it needs to share an electron. So it can only single bond. If we look at the chart, it says family 7, hydrogen, single bond. So chlorine can only bond with 1 electron at a time. The carbon needs to bond 4 different ways. Okay, so we're only going to use 1 carbon with 4 single bonds. Okay. And then we predicted we would need 4 chlorines. We have 1 to hook to here, 1 to hook to here, 1 to hook to here, 1 to hook to here. So again, chlorine is single bonding, and the carbon has its 4 bonds taken care of, 1 with each of the 4 chlorines. And each one of these lines represents a pair of shared electrons. So when we go to build the dot diagram, we need to put in these bonds first. So we have a pair of electrons that's being shared right here, and a pair of electrons that's being shared right there, and a pair of electrons that's being shared right here, and a pair of electrons that's being shared right there. If we look at the dot diagram for carbon, carbon is supposed to have 1, 2, 3, 4 electrons. And we can see 4 black spots here. So the dot diagram for carbon is now complete, but each chlorine only has 1 dot in its dot diagram in this molecule drawing. Each chlorine is supposed to have 7. So we need to complete this. We need 2 here, 2 here, and 2 here. Now we have all 7 of the chlorine's blue electrons, plus the one that is sharing with the carbon means that it has 8. And this chlorine needs the same thing. And this one around over here needs the same thing. And this one over here needs the same thing. Now, if we look, each of the chlorines has 8 dots around it. So that represents its full outer energy level of 8 electrons. The carbon has a full outer energy level of 8 electrons. So this is really kind of a good example. Everybody has full outer energy levels of 8 electrons around our symbol. We don't need these other bonds, so we're going to throw them away. Our formula is 1C, 4 Cls. So we have C, Cl, 4, because there's 4 chlorines. And we write the name of the first element. And then we see the 4. We want to say 4 chlorines. So we write tetra. And then we put IDE on the end of the second name. So it would be carbon tetrachloride. That's all there is to this page. So let's take a look at the next one. All right. The next one, it says we're going to bond oxygen to chlorine. So we look on the periodic table, we find oxygen is in family 6. It has 6 valence electrons. So let's go ahead and make its dot diagram and put the 6 dots in it. 4, 5, 6. We can throw these 2 electrons that we're not using into the trash. And in chlorine, we look is in family O. We look at the oxidation number of oxygen, and it's 2. So it needs to make 2 bonds. And 6 plus 2 is 8. It's going to fill up its energy level. Family 7 valence electrons. The oxidation number is 1. Again, here we can crisscross the oxidation numbers. So we predict in our formula we'll need 2 chlorines and 1 oxygen. The smallest number of bonds is going to be a single bond, because 1 is smaller than 2. Oh, we forgot to make that. throw this one away. The chlorine only needs to share one electron to fill itself up and have 8. So it only needs to make one bond, and it can only share one electron at a time. So it would be single bonding. So when we look at the chart, the way oxygen single bonds is like this. It makes 2 single bonds. So we predicted we would need 1 oxygen. We would need 1, 2 chlorines. So when we go to make the dot diagram, remember that each one of these lines represents a pair of electrons being shared. So we got a pair of electrons being shared here with the oxygen. We got a pair of electrons being shared here with the oxygen. Look up here at the dot diagram for oxygen, and it should have 6 dots. We only have 2 with these electrons being shared with 2 black ones. So we need to add 3, 4, 5, 6. Oxygen has that full outer energy level of 8. These 4 electrons that it keeps to itself, plus these 4 that it is shared. So we don't need these other bond types. We can throw them in the trash and get them out of the way. We look over here, each chlorine should have 7 dots in its dot diagram. We only have 1 blue one here. So we can see that we need to add 3, 4, 5, 6, 7, 8. And the other chlorine needs the same thing. Again, now we see that there's 8 dots around the oxygen and 8 dots around each of the chlorines. So everybody has full outer energy levels. The formula is 1O Cl, 2 chlorines. The name of the compound would be oxygen. We see the 2, so we write di, and then we say IDE on the second word. Oxygen dichloride. This next one says we're going to bond carbon to oxygen. So look on the periodic table, oxygen is family 4. It has 4 valence electrons. It has an oxidation number of 4. So we put the dots on the carbon's dot diagram. It has 4 dots in its dot diagram. So let's go ahead and have those as pairs of 2 working clockwise for purposes of this class. And we're going to trash these electrons here that we're not using. We're going to bond to oxygen. We look on the periodic table, it's in family 6. It has 6 valence electrons, and it has an oxidation number of 2. So we're going to put the 6 dots for the 6 valence electrons in the dot diagram for oxygen. Trash these other 2. We don't need them. Okay. This is where we can crisscross. We can crisscross 4 to 2. But we can simplify that. Okay. We can simplify this to 2 to 1. Okay. So remember, you got to simplify to the lowest amount. So 2 goes into 4 2 times, and 2 goes into 2 1 time. So we're simplifying this to 2 to 1. So we're saying that we're going to need 2 oxygens and 1 carbon. And the smallest number of bonds is double bonded. So when we go to look at the pictures, we should only find molecules that have double bonds. So when we look, the way carbon double bonds is like this. Oxygen double bonds like this. So what we have are 2 oxygens that we predicted, and 1 carbon that we predicted, and they're double bonded on both sides. Now remember, each one of these lines represents a pair of electrons. So this is 2 pairs of electrons, and this is 2 pairs or 4 electrons. So let's go ahead and put in these double bonds. We can trash these other ones because we don't need them. Carbon is supposed to have 4 dots. Here they are, 1, 2, 3, 4. But each oxygen now only has 2, and it's supposed to have 6. So we need to add in 3, 4, 5, 6, 3, 4, 5, 6. Now, with these electrons being shared, okay, there's 4 electrons, plus 2 is 6, plus 2 is 8. So there's 8 electrons for the oxygen. Over here, the other oxygen is the same way. And then with the ones being shared in the middle, the carbon has 8 as well. The formula for this compound is 1C, and then you have O, and there's 2 of them. So make the name of the compound, the name of the first element is carbon. And then there's 2 oxygens, so we say di. We put IDE on the end of the second element. So it'd be carbon. Now this last one, okay, it says we're going to bond carbon to sulfur. So we look at the table, carbon is found 4, there's 4 valence electrons, this oxidation number is 4. So we're going to put 4 dots on the dot diagram to represent those 4 valence electrons. We're going to put these electrons we're not using over here in the trash. Okay. Now we look, carbon is in family 6. It has 6 valence electrons. It needs to make 2 bonds because its oxidation number is 2. So we're going to put the 6 dots on the dot diagram. We're going to throw these 2 electrons that we're not using into the trash. Again, we could take the 4 and put it here, and the 2 and put it here, but we could simplify that. So 2 and 1. So we're predicting there to be 2 sulfurs in the formula and 1 carbon. The smallest number of bonds is 2, so when we look for the pictures, they should be double bonded like this. So carbon is going to be double bonded on both sides like this. We can double bond to 1 sulfur and then to the second sulfur. So just like we predicted, there's 2 sulfurs in the formula and there's 1 carbon. Remember that each of these lines represents a pair of electrons. So we have 2 pairs over here, or 4 electrons. So it's going to double bond like this. On the other side, there's another double bond. We can get rid of these unused bonds and put them in the trash. Look up here, carbon should have 4 dots in its dot diagram. And down here, we have 1, 2, 3, 4 black dots. So we have all those. But each sulfur is supposed to have 6 dots in its dot diagram. And here we only have 2. So we need 3, 4, 5, 6. 3, 4, 5, 6. And then again, with the electrons that sulfur owns plus the 4 that it's sharing, it has 8. The 4 electrons that this sulfur owns plus the 4 it's sharing has 8. The ones that it's sharing in the middle here, the carbon has 8 electrons. So everybody has full outer energy levels. In the formula, we have 1C, we have S, and we have 2 S's. So this would be 2, and then the name of the substance would be carbon. And 2 is a di, and then IDE on the end of the second element. Carbon sulfide, and that's all there is to make these molecules.